And welcome to the farmyard, where we make animal noises for for no specific reason. I don't know why. Where did all of that begin? It started with Sion's moo, which I think came from moof, which was like an early Apple insider joke with the dog cow. I don't actually know. Okay, so Conan should be Conan the Dusttroyer. D-U-S-T-R. That's the robot vacuum cleaner's new name now. I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. Yes. Gotta do the important stuff. Where am I? Okay, so I have a few things open. I've got Discord open. TTS does not seem to be working again. I'm getting a cannot be reached error. So unfortunately, we have another week without TTS, which is very sad. Maybe if you shout loudly enough at your computer, I will hear it. We can try it. See if we get anywhere with that. So I'm gonna very quickly skim down through the chat, see who I can find here. So good morning to Amanda, Henrik, Paul Schultz. Good morning, South Australia. Sharky, Crispian, Tabraze, Michael Wise. I'm probably going to end up repeating myself here because I'm reading names and you know what my brain is like. Lionel, welcome and thanks for coming to the barbecue last week, Lionel. That was cool to meet you. Who else? Scott Miller, Stephen George, Johnny Bergdahl, Tech Nebulous, Matt W, Scott Miller, Mr. Fix It 1952, and Jordan. Good morning, Jordan. Who else? Grant Maisels is here as well. Good morning, Moo. Ludinif. What did... Wagon Loads, yes, you made it. Henrik says, I'm so happy my package arrived at Sydney's DHL pickup point finally. What? What package is that, Henrik? What package are you waiting for? Hang on, and it says, arrived at Sydney's DHL pickup point. Have you ordered something from Australia? I don't get it. Okay, Andrew, good morning. Andrew Ruthven, that is. Scott says no Austin this week. He is lost out in the wild again, though he seems to have his LED collection with him. Oh, that's sad. We'll be missing Austin today. So, Henrik says, I've sent a 10 kilo package to Dave Jones. Okay. Michael says, DHL do parcel lockers much like Ozpost. Yes, that is a big package. Okay, now, before I get into other stuff, I have a couple of things today. But first, I want to continue the thing that I was doing last week with trying to normalize being proud of things that you've achieved. So last week I talked about Amanda getting her certification for I can't remember, EMT, emergency medical technician, I think it was. Is that the correct term, Amanda? And that is a big achievement, so it's something that she should be proud of. So now, Michael said, though 10 kilograms probably that's not going in a locker situation. Yeah. Henrik says the shipping cost was 203 euros. Wow. That is a lot to justify sending something to Dave. Yeah. Okay, so what have you done recently? It doesn't have to be in the last week, but part of saying within the last week is trying to normalize being pleased with small achievements, because often you can't, like, big things are great, but they don't happen that often. If you can start becoming happy about achieving little things, then it keeps the it keeps the whatever, you know what I'm trying to say. Keeps the oxytocin high, little spikes. So Henrik says, I hope next year I can send you more candy and chocolate to help with your diet. Thank you. Yeah. Do that when I'm in a bulking phase. Okay, Amanda said, yes, EMT, emergency medical technician, is right. Yeah, that's really cool. That is very cool. So that is an example of a major achievement. And yeah, and Amanda should be proud of that. But also, there might be little things that you have done. Little achievements. I'm trying to think of what I have done during this week that I'm proud of. I don't know. I've done a few little interesting things. Don't know that there's anything specifically I'd say I'm proud of, but I'm going to try to pick something, because I can't ask you all to bring up things that you're proud of when I won't do the same thing for myself. So, what have I done this week? Okay, a little achievement is I made some brackets to go in the stencil printer for holding PCBs. So one of the issues is the way the stencil printer works is that PCBs need to be accurately located and held at a certain height above the bed, so that when the stencil comes down, it just contacts the surface nicely. So the vertical position is important, and it has to be very rigidly held X, Y, and rotation, X, Y, Z. So it comes with these little adjustable brackets that are machined out of aluminium with pins in them. The pins that they came with are 3mm diameter, so that if your PCB has 3mm locating holes in it, you can sit it on this little bracket. The problem is, by default, when you have panels made, they have locating holes in the corners-ish that are 2mm from JLC at least. It's probably different, and you could specify, you could put your own holes in there if you panelize it yourself. And so my panels would not fit. The first few that I did, I just got out a cordless drill, drilled a 3mm hole through the 2mm, like I drilled the 2mm holes out to 3mm, and then it worked fine. And then I was thinking about making little adapters to put 2mm pins in. Sorry, while I'm talking, I am looking through. I'm looking through Fusion to find this. So, yeah, it's this was like, I'm going to bring it up in a second. Yeah, this was like a whole 10 minutes of modeling, and I made, it's a little bit hard to see. Let's make it something else. Appearance. Let's go for, what do we go for? Plastic. Plastic? What plastic should we pick? Let's just pick something that's like a mid-tone color so it's easy to see. Let's make it polyamide. Kapton, there we go. Now it's easy to see. And so there is, this sits on the bed. There is a grid bed with threaded holes, and a bolt goes down through this slot. There is a 2mm pin that goes into this hole, and it protrudes up about 1.5mm above the hole so that it doesn't go beyond the surface of the PCB. And of course, if you're using thinner PCBs, it needs to be less. So this is like the simplest thing that I've modeled for a very long time, and it really was like under 10 minutes from, I think I want to make that, to having it, the print job starting. So, borderline. That's something I'm proud of. So, okay. Oh, okay, let's see. I've got to check on the chat, see what people are saying. Okay, Andrew says, finally was able to take my 11-year-old to a harp lesson. She'd expressed an interest at the start of the year. Cool. That is cool, Andrew. So the harp is a very, in modern times, the harp is a very unusual instrument. And it's so rare to come across them, or anyone playing or performing with them. But they can sound amazing. They've got, yeah. I've seen a couple of harpists who are really good, and it's a very interesting sort of instrument. The only problem is they're so big. Trying to move them around is a total pain. Okay, Wagon Load says, like designing a 5200 GW orbital Ferris wheel. What is 5200 GW? What is that? Gigawatts? I don't know. What is a 5200 GW orbital Ferris wheel, Wagon Loads? Also, good morning to John Whips, who is now here. David C. Oh, and then Andrew said, and my daughter loved it. That's really good to hear. Crispian says, oh, so this is something Crispian is proud of, which is outside the box. Migrated my OS to a larger drive despite super bad blocks, etc. trying to stop me. Congratulations. That is really good. I know that dealing with your hard drive issues, it's something that you've been trying to sort out for a while. And it is really cool that, hang on, while doing that, I'm going to open a couple of other things while talking. Yeah, it's really cool that you've made progress on that, so congratulations. Okay, so Jordan said something, where was it? My business is back in the black for a second month in a row, which, by back in the black, I mean making enough for my family to survive. Well, congratulations, Jordan. That is cool to hear. I'm glad that it's that your business is on the right track. That, yeah, having your own business and staying alive, keeping it going, that's a really big achievement. So congratulations. That's cool to hear. Mr. Fixit says, I finally replaced all the burned walls and I'm now finally sheetrocking. Congratulations, that's a good thing. So for those of you who don't know, Mr. Fixit, 1952, who is here in the chat, had a major fire at his house. When was it? It was a while ago now. It feels like it was like late last year or something. And posted some photos of the damage, and it was bad. So if you have done repair work up to the point of sheetrocking, which is almost at the point of painting, that is really good progress. So Mr. Fixit, that's really good. Yeah. Nice. Paul said concrete. Was that about the texture that you thought I should put on this? Probably. Crispian says, after a year of delaying, finally rewired my spotlights to make them switch off legally when low beam's active. Yeah. Yeah. Outside the Box has been obsessed with car headlights, I think almost since I met him, which was a very long time ago. Yeah, I can remember back at the age of like 18, 19, 20, when Crispian would do things like park in front of a wall, like some distance back from it, and fine-tune the headlights on his car to get the angles just right so that he was watching the beam pattern on the wall and aligning everything. So, Wagon Load says, yes, gigawatts. Ooh, that is a big Ferris wheel. Tabraze said, is that a Back to the Future reference? Now, in Back to the Future, didn't they say gigawatts with a J? It's gigawatts. David says, some weird guy helped me to fix my mechanical keyboard so I can actually use it again. Cool. That is excellent. Simon said, got the first cut of software running for the core of our next generation of satellites. Wow. Okay. That's a big achievement. That is definitely something to be proud of. Oh, another one, Mr. Fix-It. I gave up on Windows and installed Linux. Congratulations. Welcome to the light side. Hang on. Wagonload says, a Ferris wheel where the hub is in orbit and the rim floats 10 meters above the ground that generates 5,200 gigawatts. Okay, mega structures. So is the prototype going to be made out of paddle pop sticks and blue tack? Andrew said, last weekend I finally got the Shelly 2 PMs that control my front door lights working reliably, created an HA automation to turn them on when I get home, near home after dark. Simple but so nice. Yeah, that's a good achievement. That is a very good achievement. Oh, Michael says, they said gigawatts, but it was gigawatts in the script, but they pronounced it wrong, but kept it because it sounded funnier. Okay. Oh, Imi says, I finished my art piece for an exhibition. I just need to frame it now. Ooh, nice. Nice one, Imi. So is there a particular exhibition that you are in the process of setting up for? Is there some event coming up? And Grant says, have now distributed 8 old PCs running Ubuntu to friends to learn Linux. Nice, nice work, Grant. That is really cool. Yeah, okay, so that is something to be congratulated on. Quite apart from the choice of OS, which I approve of. That is very good. Just the idea of rejuvenating old hardware so that it sees more use and doesn't go to landfill. That is a really cool thing. Oh, Wagonloads has an interesting idea. I'll get to that in just a second. Yeah. Okay, sorry. I'm still reading chat. Has Wagonloads been at the solvent again? John Whips. No, I think it is probably a good idea. So the point is, Wagonloads' suggestion was, instead of using this, hang on, I wonder if I can explain it better with a photo. I don't know if I have a photo of the stencil printer that is, oh maybe, I will see if I can find one. And then I'm going to get into a quick conundrum about the conveyor, and then, hang on, I'm just going to do this, and where are we? All right, while I'm looking, I'm just going to stick this up on the screen and let that play. Gives me like 35 seconds to find what it is I'm looking for. Okay, I am looking for, yes, that's me. I'm looking for a picture of the stencil printer so that I can show you how this locating mechanism works. Also, I've got some other things I can show you too while I'm here. I just went past a video. Come on, where is it? Okay, maybe, oh yeah, I can show you on this. Okay, get that out of the way, bring this up. So this is the stencil printer, and if we zoom in on the, come on, zoom, you can see right there the alignment mechanism. There's normally a stencil, so you can see the black pieces on the side, those are what hold the frame of the stencil, and then you screw down these thingamajiggamies and that holds it in place. Now here you can see the aluminium locating brackets sitting on that table, and you can see that they've got these big knurled, I think they're M6 bolts, like knurled head M6 bolts that go down through them so that you can slide them and rotate them to any position. And these little pins go into alignment pins on the PCB or on the rails of the panel if you're panelizing. And then this aluminium block in the middle is 20 millimeters thick. These are 20 millimeters high, so it provides that provides support through the middle of the thing. Anyway, I needed a version of this that instead of having 3 millimeter posts had 2 millimeter posts, and that is what this is for. So I've printed some, put them on the machine, they're on it now, and they work nicely. So anyway, that was all that was about. Oh yeah, that's right. I just came across some other pictures. Did I show you pictures of Matt's hexapod robot last week? I can't remember. Let's try this one. Let's see. So this was on my workbench like before last weekend, when there's a date on it somewhere. 8th of the 9th was when we had this on the bench, and that's it, just kind of moving around a little bit. And you can see the laptop down here is what's controlling it. So this is a project that Matt has been working on for quite a long time, and I think it's close to 15 years when he started doing this, and then put it aside for many, many years. It sat in a box, and then about 2 weeks ago he got it out and connected up all the servos. Actually no, it was more than 2 weeks ago. It was a while ago that he printed some of these pieces, because the original had some laser cut pieces, and he's replaced them with these 3D printed pieces. This is all being controlled by MATLAB at the moment. There is a servo driver board on the hexapod itself, and that is what sends the PWM signals to all the servos. And then this silver cable that you can see coming down here, that is a serial cable going to a USB to serial converter, and then all of the logic to control it is on the laptop in MATLAB, which has a mechanical simulation of the geometry of the robot, and that's what does all the calculations of movements, like what it's trying to do. I don't know if this is the same. We took a, I know this one, I think this is just it standing up. Nothing more than that. It was going from lying at rest on the table to, hey, stand up, and then it goes wink. And somewhere we got some video of it doing other things. No, that might have been on Matt's camera, on Matt's phone, so I don't have it here. There was, yeah, there were some other videos of it on the floor. About a week later, he brought it back here, and we had it down on the floor behind me, walking around a little bit and doing stuff. Anyway, his plan is, he was going to try to bring that along to the barbecue last weekend, but things got in the way, so he didn't end up bringing it. Wagon Load says, make a hexapod with hoverboard wheels for feet so it can walk and roll. Yes, there is a combination of wheels and legs is such a powerful and flexible adaptation for robots for mobility, because it gives you, hang on, I'm gonna see if I can find this. I've seen this done a few times, and it is a plan that of which I thoroughly approve. Robot legs with wheels. Yeah, this sort of thing. Hang on, I'm gonna bring this. Oh, this is crazy. Hang on, I'm gonna bring this up. Yeah, because the thing is that wheels are fast. If you've got a good surface and you want a robot that is going to move somewhere, build a car. I mean, there are reasons that we don't drive around in walking vehicles. We move in rolling vehicles. And it's because a wheel is so efficient and smooth and fast. But wheels can be stopped by things like stairs and other obstacles. So legs are very useful for that. But what happens if you put a wheel on the end of a leg? Then you get things like this, which is kinda crazy. It's yeah, you can have something that uses its legs as a way of moving the positions of the wheels on flat ground. It can go extremely fast because it can just spin the wheels and move like a car, but it can also walk, and it can lift itself up over things. So yeah, wheels on legs are it is a very clever way of doing things. Yeah. Oh, David said, what is that? The one that's like 15 years old and we saw it at the barbecue last year. He might have brought it to a barbecue in the past, but it wouldn't have been powered up at the time. Oh, what Crispian just said, pancakes for breakfast here now. Sorry, I've missed a whole lot of the chat because I've been busy talking and showing clips of things. Stingray was cooler. Yeah. Stingray is pretty cool. Let's see. What is this one? Oh yeah, hang on. I'm going to put this one up just because. Just for a bit of the serenity. Oh look, we can listen to birds as well. So this is obviously very, very low tide. Now, where are we? Can you smell the pancakes? Asked Crispian. Oh, Jeff said, if you get a chance, have a look at Menzie Muck Excavator for an example of this. Really? Menzie Muck Excavator. Walking excavator? What? So is this the same thing but on a massive scale? I'm just opening it now. So we're about to find out. The world of walking excavators. Walking. Yeah. Okay. Let's try this. I want to see a video. Come on. Video, please. Walking excavators. Yeah. Okay. It looks like there's not much that would stop that. Is this going to pull up a video? I want a video. Ah, so there's an excavator with wheels on it that lets it go on a train line. With a very well-timed photo, if that was real. These photos look like AI, don't they? I don't know if they I actually don't even know if it's real or if it's just an extreme filter, like adding real intensity, high dynamic range to the image. Walking excavators. Pretty cool. Yeah, Michael says, well, Mars will be colonized now. Okay, that is, oh yes, and hello to Jeff Miller, who I don't think I said hello to earlier, and SK Photo Guy. Who else has arrived since I did the hellos? Not sure. All right, so here is my conundrum. I want to get through this fairly quickly because I want to do an assembly. In fact, I am going to go and turn on the reflow oven. That is because I want to get it up to temperature. That is how much I want to push this along. Oven on, wait for it to boot, and go. Okay, the oven is now heating. I even started the pick and place machine before the stream because I want to do a board assembly. Now, but not of this one that's on the stream. This is the conveyor controller. And I have one assembled. I assembled one yesterday, Friday? I think it was Friday night. It's a blur, I can't remember. And there is a problem. There is a problem. Not with the control board. So far, the control board seems to be working perfectly. Everything about it is working. And I can, in fact, I should demonstrate. I could and should demonstrate. And then, and in fact, that will help me with explaining what the problem is. So this is the old control board. That's the old control board. And if we switch to overhead camera view, there, where's the camera? There. This is the old control board. And so the focus is a bit closer down to the bench. I've got to try to move things around to get it in the camera view. And this is the new control board, the green one that you can see just down to the left there. I'll give you a better view of that in a moment. In fact, I'll give you a better view of it right now. I'll move that back so that I can move this under where the camera is. So this is, oh, I'll turn on the, got to turn on the bench supply. This is the updated design. You can see that I have jumped it around the emergency stop so that it can power up. This is these two connectors are for CAN bus and power, so they can be all the conveyors can be daisy chained together. And where am I? 12 volts, 1 amp, that'll do. All right, so this is now powering up, and you should see in a moment it'll come up on the display. Conveyor starting. That's all it says. It only ever says starting. I've got the 3 PCB sensors plugged in. I've got the 2 DC motors plugged in. I've got the stepper motor connected for the Y-axis to move the conveyor backwards and forwards, so the width. And you can see the little ULN 2003 chip on there, which is just a bunch of Darlington transistor pairs. And the new surface mount fuse, thanks to Austin's inspiration. ESP32S3, we've got RGB LED, which is not doing anything right now. We've got 4 inputs on dip switches, which also are not doing anything right now. I'm not doing anything with them in the firmware. This is to be able to set the CAN ID by just changing some dip switches so that I can have a series of conveyors and configure which one is which, so that they know what their neighbors are, like the number above and the number below whatever your current number is will be your neighbor. So the conveyors can talk upstream and downstream to each other over CAN bus. What else? And that's about it. So here is the conundrum. The little 28 BYJ 48, I think is the part number, for the Y-axis stepper is working very nicely through this. I can control it well. the board sensors are working nicely. The H-bridge for the DC motor works. Problem is the motors. And this is my conundrum. So I'm going to move this back down under here so that you can see it. In fact, I'm going to see if I can zoom out and fix that focus a bit more. I'll zoom, that's as zoomed out as it gets. That focus isn't too bad. But then I'm going to move all of this so that you can see the y-axis moving. And I'm going to, I will home it. So I'm back at my computer. You can't see me, but that's okay. I'm just going to open Arduino IDE so that I can use its serial terminal and send some G code to it over the serial console. The way this code is set up, it connects to Wi-Fi and to an MQTT broker, and it is controlled by G code, but it doesn't actually care how that G code gets to it. You can control it by publishing G code to MQTT, and that will work. You can send it G code over CAN bus, and that works. Or you can send it G code on the serial console, and that also works. Just getting it open. Yes, I know you can't see this, but that doesn't really matter. Still waiting for it all to open. Okay, here we go. Oh, do I have it plugged in? No! That's why I can't see the... I need to move this a bit. The reason I couldn't see the serial console is this is not plugged in. Okay, now it's plugged in. And now do I have a serial console? Yes, I do. All right, I'm going to hit... I need to move this a bit so you can see it. In fact, I'll move it. I'm going to rotate the whole thing to there. So this is the back of the conveyor. The front is down here. And I'm going to tell it to home. So I'll send it a G28, which is a homing command. And now you can see that it's moving. And in fact, I'm going to get down close to it and be quiet for a moment. Now, could you hear that? That is almost dead silent. Because there's other stuff going on, like the dehumidifier and stuff in the clean room, when this is moving, I can't even hear it unless I get down close, and then it's very, very faint. So I'm just going to send it a command like G0 Y, I don't know, Y150. So this is going to tell it to go to a width of 150 millimeters. And now it's moving. And also pay attention to the speed at which it's moving. So this is, I think the stepper is running at 14 RPM. And now, what did I tell it to go to? 150 millimeters. And there we go. It's about 150 millimeters. I think that's still slightly out of focus, so it's hard for you to see, but that width of the conveyor is now 150 millimeters. Yeah, so that part of it is working very nicely. Now, the issue I have is over the selection of motors for the x-axis, and there are some options. So what's inside here is a little N20 DC gear motor, and that's what I was running, but they are very weak and they stall easily, particularly if they're running slowly. So then I ordered these motors, and this one has a right angle gearbox on it. Is it screwed together or just pushed together? No, it's just pushed together. So I can take that apart. There we go. So there's the back of it. It's like an N20 motor, but scaled up. I think it's an N50. Yeah, so my thought was, and also because it's so much physically bigger, I had to get the right angle version so it would go down inside the tube. My thought was, because it's so much bigger, I could get it with a higher ratio gearbox, and then I could run them slowly and still have enough torque. problem is, and it actually does work, like if I plug this in now, no, not this one, I don't need to. I've got this one plugged in. So this one, which is just off the edge of, see the cable comes out of the frame. The idea is the cable goes through there, this slides into the end of the frame, and the belt goes around it. Now, I've just got it sitting out here to, yeah, for testing purposes. But this is the bad thing. I am going to send it a command of, let's see, M03, which means, so I'm using the M03 for rotate right, M04 for rotate left. They're spindle commands normally in G code, but I'm using it for the movement. So M03 at a speed of say 1,000. So that's 1,000 millimeters a minute, or a meter a minute. I'll hit enter. And now, listen to this. That is such an annoying sound. And that's just with one of the motors going. In fact, I'm going to grab this motor and plug it in here so that we've got two of them running. There we go. So now we have two of those motors running. That sound is going to drive me nuts. And the thing is that it's not just the sound that's an issue, it's also the speed. The slowest that I can make it go, so this is the problem. In fact, I'm going to stop that so that we're not sitting here listening to it. So I'm going to send it an M05, which is a stop spindle command. There we go. So the problem is I need a wide range of speed on these motors for the conveyor, because I need to be able to make it move very slowly, like 140 millimeters a minute, you know, that sort of thing. 140 millimeters a minute is very slow, like it's barely perceptible. If you just glance at it, you wouldn't even tell it's moving. If you look at, well, yeah, 140 millimeters a minute, you can tell. But once you start getting down to like 90 millimeters a minute or 100 millimeters a minute, you have to actually just stop and look at it for a moment. And when you've been looking at it for a second or two, you can tell that it has moved slightly if you've got some kind of a visual reference. So I need to be able, and the thing is that that is the speed that the reflow oven runs at. Commonly it might be 115 millimeters a minute, or it could be 140 millimeters a minute, depending on the reflow profile. But that's basically, like, it's in that ballpark. It's in the low hundreds millimeters per minute speed. And so to deliver a PCB from the conveyor into the reflow oven, ideally you want the speeds to be pretty well matched. It could go slower than the reflow oven. The problem is that if it goes faster and you have multiple boards on the conveyor, as the first board comes off and moves on to the slower conveyor, like the next one in the chain, PCB, it'll start to slip, and then other PCBs can catch up and bash into the back of it. I have had that happen in testing. And of course, as Sion would say, the answer is, well, don't put multiple PCBs on the conveyor. Yes, I know. But this is an example of, it's just one of the limitations. So I need to get around the problem of making this run slow enough to match the speed of the next conveyor, which in the worst case scenario is the reflow oven. I'm pretty sure that the profile I've been running recently on SAC 305 solder is 115 millimeters per minute. So very slow. And it also needs to be able to run fast enough to not be a total pain when it is trying to interface with things like the pick and place machines. Now the KO pick and place machines run their conveyors very fast. I don't know, I did actually measure it at one point. It's something like, I think it was something like 20 meters a minute. It's like, you know, like 20, so instead of being 115 millimeters per minute for the reflow oven, it's 20,000 millimeters a minute for the pick and place machines. And that means that if you're going to match that speed, so when you're passing boards between conveyors, ideally they should be running at the same speed, or you get jamming problems and twisting problems and things. I need to be able to make this conveyor run at anything from 115 millimeters a minute to 20,000 millimeters a minute, all configurable from software. That is a real challenge, and it's been proving to be difficult. I can't make these motors run slow enough. They stall. So as an example, I'm going to come back over here and I'm going to set this to, I'll try it at 700 millimeters a minute. Yeah, so this now, I'm going to put something on it so you can see it. All right, that rate of, whoops, the calculations based on the circumference of the wheel, all of that sort of thing, means that if it's running at this rate, at this RPM, that is approximately 700 millimeters per minute of surface speed if you take the tangent from the radius of that wheel with the plus the thickness of the conveyor on it. So that is about 700 millimeters per minute, which is about 5 times as fast as I need it to go to deal with the reflow oven. So I need to make it run a lot slower than that, and I can't. If I try to slow it much more than this, the motor just stalls. So if I go to, let's see, so that's 700, I'm going to go to 600. So that's now at 600, I'm going to go up to, I'm going to go to 500. Now this is continuing to work because I started it fast and then slowed it down. If I had tried to start it at this speed, it wouldn't have even started. Now I'm going to drop it to 400. Okay, so that is 400. Well, we're getting down into the ballpark. Let's see if I drop it to 300, what's going to happen? 185. Have I hit a... Oh, no, I see. It's not actually running at that because I've got a cap in the code where it's not letting it go below a certain speed. So that is actually... Yeah, I'm not even sure what this is now, but I'd have to look up the thing. And then if I go to... So say I go to 2,200, which is the other extreme. So that is running it pretty well flat out. So that's about as fast as it goes. I would need it to be going... So the slowest speed that it can do is not slow enough, and the fastest speed that it can do is not fast enough, which is interesting. So one thing I can do is the conveyors at different parts of the system can, yeah, they don't need to cover the entire speed range. So what I could do is use different gear ratios depending on which part of the production line it's going in. The short conveyor between the two KOs only ever has to run at KO speed because it's bringing boards in from the first KO and it's sending boards into the second KO. So what I could do is pick motors with the ratio that gives me the high speed that I need for that, and then the conveyor that feeds into the reflow oven, for example, I could make it run at a lower speed with a higher gearbox ratio. I'm going to stop that now. Oh, but before I do, listen to this. I don't know how well it's coming through on the microphone, but that's the sound of the motors running. Now imagine if there were 7 of those in the room with you. It would start to become rather annoying. Okay, back to chat. I haven't actually seen chat for the last 10 minutes or so. So, where are we? Any mules? Welcome. Oh, an SK photo guy. Hello. Any mule says, colonize the gas giants with robotic stingrays that swim in the skies. That sounds like an awesome plan. Oh, Wagon Loads asked, does the angled edges on the PCB each side of the ESP antenna help boost range? Okay, so not really. Well, yes, to some extent. The idea is that you shouldn't have anything too near the antenna. And what I did, now the thing is that with a PCB like this, the way the outer geometry is created is by routing it with the CNC machine. So at the PCB factory, they mill the edges to get the shape. And what you see a lot of people do is they'll come straight down and then they'll just cut a rectangle out of the side and then straight back again. I don't know why, but some years ago when I started doing these sorts of things, I just started angling the edges out in order to maximize the clearance around the antenna so that there is nothing coming up right beside the antenna. Otherwise the antenna ends up effectively like in a box. So I'm just trying to make sure there is no copper or anything too close to it that could be influencing its signal. And when the CNC machine comes along, it makes the job really easy because it just comes along here. You'll end up with a slight radius on there and a slight radius in here, because typically the edges of the PCBs are milled with a 2mm flute, like a 2mm mill bit, whatever the terminology is. So you end up with a 1mm radius because it's a 2mm diameter bit. So yeah, a 1mm radius inside there. And by doing it as these nice gentle angles, it just, I don't know why, but it just feels to me like I'm being nice to the CNC machine that's cutting out the board. Because it's not coming along there and then doing straight and then straight and then straight out there. It's like a nice little detour for it. So I can just imagine the tool path on the CNC machine going and then continuing back on back on its way. Much louder. Oh, Crispian said, would it be quieter if they were loaded? So this is talking about the motors. And would they be quieter if they were loaded, as in under load, as in pushing against something? Wagonload says, need a screen timeout so the OLED doesn't have pixel burn. Yes, I know. Sorry, Crispian's question was about whether it would be quieter when loaded. I don't know. I think it would just be more prone to stalling. Stephen W says you could binary count the address for 16 conveyors. Yes, exactly. That's my plan. What I want to do is use the 4 dip switches to be able to set any one of 16 IDs. So it's just going to be binary. Where are we? Wagonload says, can't you slow it down with PWM? Oh, I am. That is how I'm making it run slowly. So these 2 white connectors here, these little JST XH connectors, are the ones that go to the motors. That is a DRV8871 H-bridge motor driver. Those 2 traces that you see here, that one and that one, they are PWM signals coming from the ESP32. So the ESP32 is PWMing the H-bridge in order to drive the motors at different speeds. But yes. Joe Gold says gears, motor fast, torque higher. Yeah. Lionel says use gears to adjust speed. Yep. And Anymeal says sounds like a gearbox is needed. The thing is that these motors already have gearboxes and they can be purchased with different gear ratios. I wonder if there is one. Can I pull it apart? I'm going to switch back to the overhead view and open this one up. And what you can see here, this is that part, the silver part there, that's the motor. This gold part here, this is a gearbox. In fact, I'm going to pull, see if I can pull the drive sprocket off and take the 3D printed enclosure off. So it's got this gearbox already, and this one, so there's a worm drive coming directly out of the motor. I mean, you are way up there at the moment, so you can't really see any of this detail unless I super zoomed in. There's a worm gear coming directly off the motor, which goes into the gearbox, and it drives this shaft, and then there is a whole series of shafts. How many are there? 1, 2, 3, 4, 5. It's a 5-shaft gearbox, so it's a reduction gearbox going to the drive shaft itself. And this already has a ratio, I think it's in the order of like 500 to 1. So it's the motor spins quite quickly. It gets reduced about 500 times in this gearbox, and then that's the actual drive shaft. But you can order these motors with different gear ratios depending on what you want your outcome to be. So this particular ratio, I can't remember what it is, but it's somewhere in the order of like 500 to 1. This particular ratio gives me a speed range that puts it within the range that I want, but it's not broad enough based on the speed variation of the motor. So I need a broader range. But that particular gearbox ratio puts it into the range that I want, within the range that I want. Some Call It Fun says, idea, run in bursts, on 1 second, off 3 seconds. Oh, that is an interesting idea. 2 is long axle spanning entire length, proper stepper and a step down gear. Yeah, proper stepper. And Jordan had the same idea, run it intermittently to get the lower speed. And Joe Gold said steppers or BLDC. Andrew said next week on John's live stream, designing a motor. Yeah, so this brings me to the point that I think all of this time I have been trying to avoid using stepper motors for the conveyor, for the belt part. I'm using the stepper motor for the y-axis to move it backwards and forwards, and as you've seen, that works really successfully. It's very nice, it's almost silent, and I thought that what I could do is get away with not using steppers for the conveyor and just use DC motors controlled by an H-bridge. But what I'm coming to the conclusion of is that DC motors are not the correct solution for this problem. What I probably need to do is go for stepper motors on the X-axis as well. And this is my conundrum now. If I'm going to put a stepper motor on there, what do I use? I could use like a tiny NEMA 8 or something. Hang on, I'm going to quickly read through extra things in chat in case there are suggestions. Michael says, the matrix is glitching several times this morning. The stream has stopped for about 0.5 seconds and jumped back 5 seconds. That's weird. Something bad going on? I'm just trying to find where is the... yeah, I've just come to YouTube Studio and it says connection is good, so I don't know. I don't know why that is. Okay, so where are we? Wagonload says, can't you use an overhead camera to see traffic jams? Why can't you send alternating speed commands with time pauses when it is too close to the next PCB? Overhead camera. Interesting. So we could use some computer vision to detect where things are on the PCB. Ooh, I just heard the reflow oven sing its little song. And what that song means is it's up to temperature, which means I've got to get on with populating this other PCB. Wagon Load says, does the angled PCB work like a parabolic reflector? I don't know. I don't know. Stephen says it will be quieter when mounted inside the tube, but with so many running, not sure that will still be enough. Oh, and Stephen asked, is it the motor or gearbox making the sound? That's a great question. I think it's the gearbox. It's like a little buzzy sound. Also, I have tried with different PWM frequencies, like the bass modulation frequency. I've tried it at 2 kilohertz, 5 kilohertz, 10 kilohertz, etc. Just checking whether I can move, like whether the PWM resonance is causing a problem. And even trying different frequencies, I couldn't make all that noise go away. Scott says, have yet to hear a valid reason for avoiding steppers. Yeah, cost is it, Scott. So cost and complexity. Now, NEMA 8 stepper and physical size. They tend to be a little bit bigger. So let's have a look. I've just picked a, all I did then was type NEMA 8 stepper. So it could be something like this. Actually, that price is not bad. That is less, hang on, where's view, actual size. That's weird. It seems to be very zoomed in. Oh, is that the ad? Why is it, I don't get it. Am I on the, why, yeah, it's like it's feeding me the mobile site instead of the normal page layout. Okay, 1.4 newtons per centimeters. So little NEMA 8 would do it, potentially. I could run one of these, or two of these rather, because I need one for each. What are the dimensions on it? How long is it? 28 millimeters. It's borderline. Okay, so one of my limitations, this is not a total killer, but ideally I want a motor that is 25 millimeters long or less, because I don't want it to protrude beyond the rails, which are 25 millimeters wide. Tabray says, have you measured the frequency? It might be a multiple of all the PWM frequencies you've mentioned. No, I haven't. No, I was playing around with this for a while yesterday, and I basically came to the conclusion that it's not that there is just one specific thing that is the problem that makes the DC motors, that kind of semi-rules it out for me. It's multiple things. So solving just one thing does not solve the problem. The lack of range on speed that it can do is a problem, and the noise is a problem. So if I solve one of those and not the other, it's still annoying. So yeah. John says, higher speed motor to put noise outside of human audible range, 20 kilohertz. Yes, that was my theory. So I only went up to, I think it was 15 kilohertz in my tests yesterday with the PWM. Generating PWM out of an ESP32, the frequency that you can generate is inversely proportional to the bit resolution of the PWM signal. So if you are doing, this is totally going from memory now, but if you are doing, for example, 14-bit PWM, which I don't need, but 14-bit PWM, the highest frequency you can go is like 5 kilohertz or something, and then it's kind of proportional to that. I'm doing 10-bit PWM, which means I can go higher in frequency, but there is that trade-off. And the other thing is that because the gearbox has all of those gears in it, if I went to say 20 kilohertz on the PWM and I eliminate the PWM noise in the motor itself, you're still going to have lower frequencies in all of the gears through the chain of the gearbox, because the output shaft is moving very slowly, and then the gears in between the motor and the output shaft are at different speeds. So each one of those is going to have its own frequency, and you can't eliminate them all. So, yeah. Scott says, AliExpress has a bizarre definition of similar. Yeah, it does. What on earth is it classifying a stepper motor as that it is saying that these are similar items? So these are magnetic clasps. These are jewelry clasps, like for a bracelet or something. I don't know what you'd use a stepper motor for. Anyway, a NEMA 8 is possibly an acceptable solution. Now the thing is that with something like a little stepper like this, you can run them very slowly. You can have them so that they are turning at a very low speed, or you can make them run pretty quickly. But I think the next thing to do, and in fact I have a couple of NEMA 8s. Alright. Oh, John says, might sound stupid, but are the gears lubricated? That's a great... that never even crossed my mind. I'm stupid for not thinking about that. You're right, I could put just a little drop of machine oil or something into that gearbox and see what difference it makes. That is true. Yeah, but but still, I am inclined to go for steppers. And oh, Wagon Load says, what about quadcopter motors? Yeah, so you're talking about brushless DC motors. Then they'd need to be tiny, and I would also need to gear them down massively, and then I think I would still have, yeah, Wagon Load says sewing machine oil. Yeah, something like that. I've got some around here somewhere, some really thin lubricating oil. So where was I? Quadcopter motors. Yeah, I'd still need a gearbox, and I think the gearbox is where a lot of the noise is coming from. Now, I have some NEMA 8s, because, in fact, I've got some hollow shaft NEMA 8s that I was using for the rotational axis on Mick or Make It, on my old DIY pick and place machine. So, oh, Simon said molly grease might be better since the gearbox is so open. Yeah. Oh, and Scott said those are open gearboxes, use grease, not oil. Grant says, how hot would steppers get? I suppose they don't need to be powered onto lock position. Don't want to melt the PLA. Yeah, that's a very good point. I'm probably going to print these parts out of polycarbonate for stability when I do the actual final parts. But you are right that steppers can get pretty warm. When they are sitting there doing nothing is when they are drawing maximum current. Steppers, this is the weird thing, a stepper in a hold position pulls more power than a stepper that's moving. So they sit there and get warm. But I think what I need to do, what I need to do sometime is find one of my steppers and connect it up to a little stepper driver and do an experiment. I want to see if I can drive it from the slow speed to the high speed through the full range and have it work nicely. And if it does, I would seriously consider replacing those DC motors with little steppers like this. Crispian said use a Tesla engine. Okay. Let's see if I'm small stepper motor. Now the 4N28 thingy, ooh, little pancake motors. These ones, the 28B, no, these ones, the 28BYJ 48s. This is what I'm using on the y-axis. I would love to be able to use this on the conveyor as well, because they are so slow. No, they're so quiet. The problem is that I can't make them run fast enough. Otherwise, these would be excellent. So, and I'm very happy with it on the y-axis. NEMA 11 stepper, that's a bit too big and strong. Is there anything that is smaller than a NEMA 8? And I don't think I'd want to go much smaller than a NEMA 8 because it'd end up being too weak. There's another NEMA 11. Senya ultra tiny stepper. No, that'd be too weak. It needs to be strong enough that it's going to be pushing a conveyor belt which has got some tension on it and boards sitting on top of it, and the boards might be heavy. They could, once they're populated, they can actually have a bit of weight to them. So I can't use anything that is too small, like this sort of thing. These tiny little cute steppers, they're very cool, but just not enough grunt in them. Okay, I need to get on to assembling a Testomatic board. Are we going to do that today? Or have I spent so much time talking about other stuff that I'm not even going to get to Testomatic? Testomatic 2.3, this is what I want to put together today. This one. Simon said, isn't it time to assemble something? Yes, you are right. Wagonlight says, high performance motor control from the ground up. Okay. Scott says, pack a whole row of the tiny ones with individual rollers to carry the boards. Yeah, and the clever thing about that is you could make part of the conveyor move while another part is stationary, so you could actually move boards relative to each other. That would be super cool. Okay, let's assemble a board. Now, I am going to... What am I going to do? Okay, first I have to clear myself some bench space because I'm going to use this area here to put paste on the board. Turn off the bench supply, move this out of the way, move that, move that, move that, move that, hook that over the top. I'm going to try not to drop everything. And I'm just going to put this over, I'm going to put it on the floor for now. Move it over out of the way. Okay, so now we have that. Oh, there's a one of the belts off the conveyor. And we have that, the stencil. But it's brand new, hasn't been used, so I've got to pull the tape off it. Oh, I need gloves too. Oh yeah, they're over there. I'm trying to be conscientious and wear gloves whenever I'm using solder paste and nasty things like that. I'm not going to use the machine for this. I'm just going to stick the stencil on it and do it by hand. Can I give myself a bit more room? A little bit. I've got all sorts of junk sitting on the workbench at the moment. Where's the alignment? About there. I will get that properly aligned in a moment before I do the real thing of putting the paste on. I have solder paste. Oh, I need gloves. Yes, I do need gloves. What else do I need? I need the squeegee. I need a knife to dispense the paste. All right, I'm going to go for a little walk because the other stuff is sitting in the clean room where it is normally used. So that, and that. This is where the, I wish the TTS was running because it's hard to pay attention to the chat. Where is it? Grant says, sometimes getting something that does 95% of the job and worrying about the last 20% later is better. Yeah, exactly. That's the classic. Perfect is the enemy of done, or perfect is the enemy of good, or whatever the phrase is. Okay, that alignment looks all right. Although what I should have done was put solder paste down before I did this. In fact, what I think I will do is, can I fit 2 more on there angled as supports? Yeah, they'll fit. Okay, 1 there, 1 there, something like that, just to give a bit of extra support to the squeegee, or to the stencil as I wipe over it. Okay, now here is your prompt. Everybody start thinking about, or during the week, not necessarily now, during the week as you are doing things, start thinking about what things have you done that you're proud of, that you can talk about next week. Bring it up on the next stream. Oh, now I've got to realign it, which is sad because I had the alignment absolutely perfect earlier. Where are the gold marks? The worst part of this particular board is the vertical USB-C connector, which is right there. And that's the one that I can't rework. So I need to make sure that is aligned. And that looks, oh, I had it. There we go. That looks pretty good. I can see gold through all of those now. All right. Time for doing this manually the old-fashioned way, like a sucker. Now I'm just going to skim, which means that all of the apertures will end up, all of the solder things will end up with the same depth. And move that out of the way. All right, I'm going to get, I will inspect that under the microscope in a second, and we shall see what that paste looks like. But first, I'm going to dump all of this back into the tub. So yeah, this is the unleaded paste, which is what we switched to a little bit ago now. I am trying to do everything unleaded, which is not very nice in some for some things. Leaded solder just flows so much better, works so much more nicely. But I should be doing the right thing, not subjecting my brain cells to any more of the heavy metal poisoning that I have subjected it to over most of my life. Probably accounts for some of my mental issues. It's probably cost me a few IQ points over the years. Okay. Oops. Microscope time. Let's see if this works. And I've got to get some focus happening. Oh, the alignment isn't great, but it's not bad. Hang on. I can't quite get the focus on the camera. Just got to move that. And there. All right, yeah, so this is the worst part of the whole PCB. This is the vertical USB-C connector. And what I'm going to do is squirt a little bit of paste into those holes but I will do that so I can do like an intrusive soldering thing, but I will do that before I put that part in. So let's look at some other parts of the board. There's the 3.3 volt voltage regulator. What else? There's a, that's one of the switch mode regulators, the LM38020s, LMRs rather, and you can see the thermal vias there in the big pad on the bottom. Those pads look pretty much spot on. You can see all of those resistors. I've got solder just nicely on them. That is the TUSB USB hub that just goes there. Yeah, what's that one? Oh, that's the oscillator for the USB hub. What else do we have up here in the top left? So my alignment was a bit off, like it was vertically off on the left side of the board. You can see it's slightly low. You can see a bit of gold on the top of each of the solder blobs there, but still acceptable. All right, that will do. So now what I'm going to do is move this down out of the way. That is the live video right now from inside the pick and place machine. So I'm going to pull up, oh come on, pull up the, why didn't this save? Oh, it won't save. Couldn't be verified. Yes, I don't care about the certificate. Just connect. And this, oh, come on. This is the remote desktop on OpenPNP on that machine. So I'm just going to shrink that down a bit so that we can see the machine. And now I can, yeah, I can move the machine to different positions. So I've got the, that fiducial, oh no, that's right, that makes sense. So this is the job for Testomatic. I've already loaded it. I haven't actually run any of it yet. Do I have any? I don't have any parts on it that are in error state, which is good. I've got a bunch that I need to put down by hand. In fact, I'm going to turn on, am I going to turn these on? Yeah, I will. I'll let the machine put these down. I think these are actually the wrong footprint. I think it's a SOD 123 that I've got loaded, and it's a SOD 323 footprint on the board. I should check that. Let's see. So, where are we? Somewhere, oh, come on. Where are those? Oh, it's there. So we can go info on that, BS5819. Oh, it's a SOD 123 footprint. Okay, so I think that's okay. All right. Now, why have you full screened? What is going on with you, Fusion? Okay, that's better. Now, yeah, so I am going to let it put them down. What else is that one? Oh, IO mod. No, I'm not putting down any of those. What's that one? TCA 9548 is disabled. The EEPROM is disabled, so a fair bit of this stuff I have to put down by hand. I think there are a bunch of resistors I've got to put down too, which is sad, but that's just the way it is. There are some big caps there. More caps. Yeah, that all looks okay. All right, so what I'm going to do is leave, how am I going to do this? I am going to expand this view and bring this over the top so that you can see the machine. In fact, I'll expand that a little bit. And that way, I'm just going to leave it like this, but I'll turn my face off. Face off. So what I can do now is drive the machine and you'll be able to see the interface of OpenPNP and you'll be able to see the actual physical movement of the machine. But first, I have to set the conveyor width. Now, what is the width of this PCB? It is about 82 millimeters. So going to actuators, set conveyor width 82, set, and it's parked, yep. Let's load a board. I don't think I've got the origin of the board set properly yet. Actuators, load PCB, go. Oh, this is going to fail for a funny reason. I better catch the PCB. And the funny reason is I forgot to turn on the air compressor. So I am going to go, I'm going to tell it to unload PCB, and then I'm going to have to turn on the air compressor. So I'm going to do that and then click on unload, on, and then take it back out. All right, I've got to do that from my phone, which means, so now I'm feeding the PCB back on the entrance side. Where is my phone? There it is. And let's see, where is air compressor? There. Okay. The compressor is on. You can probably hear the hissing. And hello. I'll have to wait for a minute for the air compressor to build up a bit of pressure so that I can get it to load. So the problem is, the reason that the board didn't load is that if you look down, where is it? Here. This little thing here is an air solenoid, and this rises as a stopper to prevent the PCB from traveling past that point on the conveyor. The conveyor deliberately overruns so that this pin comes up, the conveyor runs, and the board bashes into the pin and it stops. And that gives it a hard locating point there so that it always ends at the same point. And then these things here are air actuators as well. And they lift these strips, which are little aluminium strips, I think. And they clamp the PCB against these top plates here so that it's jammed in position. And none of that stuff works when there's no air pressure, which is why loading the PCB failed. I'm going to try loading it now because it's probably got enough pressure for it to work. So what we should see is this little pin rise up just before the conveyor starts running. There we go, and go. There it is. PCB bashes into it and it gets clamped into position. So now I can, I just want to see how far off this is. Oh, it's actually not that far off. I've got kind of approximately the right position selected. So I'm going to do a manual fiducial location on this. And yeah, at some barbecue, it would actually be cool to do a proper run, like run the pick and place machine, do a full job on it. The thing is that there's a lot of faffing around and it's not particularly interesting to watch. So why is that one at 270 degrees? That's weird. That particular fiducial is rotated. So now what I can do is just pick apart like this one, this 100K, and go to it, and you can see that it is aligned, and that 22 UF, and that one is aligned. So all of these parts now should have their coordinates corrected based on the location of the PCB. So I'm going to close the cover in order to make the light conditions predictable, and then we'll hit go and see what happens. You can see in the window on the left, that is the up camera from OpenPNP, and it's using that to do alignment of the parts. You can see the red bounding box that it draws around each of the parts. That is where it's detected that the part is, so that it can apply corrections. And if you look up in the top left here, you will very briefly see some overlay text. And in that one it said X minus 0.004, etc. So it's got X, Y, and C. So C is the rotational axis. In that case it's 0.286 out of alignment. That one is 2.727 degrees out of alignment. Delta, it's showing the delta on there. So that is its detection of the actual position of the part and the corrections that need to be applied in order to put it down in the right place. So hopefully it is putting things down in approximately the right place with those corrections applied. What are we up to? So we're at 34 placements of 94, so it's a third of the way through, a bit over a third of the way through. So it's not going to take all that long in the machine to do this board. It's on to the 0603 parts now, which is why, and there's only one nozzle in it in the machine at the moment, which is set up for 0603 parts. For the first part of the run, what it was doing was a mix of 0805 and 0603 parts, which is why it was using one nozzle for picking up 0603 and a second nozzle for picking up 0805, and it was doing 2 parts per run to the feeders. Now it's only doing 1 part because all of the 0805 parts have been put down and it's only got 0603 parts left to do. So there's only 1 nozzle available. One of the things I want to do is set up, I need to optimize the nozzle setup. At the moment I'm only using 2 nozzles out of the 4, even though the machine itself could be using all 4 nozzles, and it's probably hard to see while it's moving around, but all 4 of those nozzles currently have different size tips in them. And they go from left to right, smallest to biggest, so that the one on the right is used for picking up things like large IC packages. The one on the left is used for picking up small packages like 0603 resistors and LEDs and capacitors. So I need to do some work on more configuration in OpenPNP and swap some nozzles around and do some positional tuning so that it can be running with all 4 nozzles for at least some of the job. And what I'll probably do is have either 2 or maybe even 3 nozzles in it set up for 0603 parts. But at the moment, the limitation on our assembly process is not so much the pick and place machine. And this machine on this particular board might take a couple of minutes to do the population, but that is not the long time in terms of doing this. These ones are interesting. You can see these are diodes that it's putting down. These are the SOD123 format diodes, the B5819s, and it's not detecting the body of the diode, it's detecting just the pins that stick out the end, which is why it looks like a very skinny rectangle. And you can see there, this is a SOT23 MOSFET, and you can see it's detecting the pins on that as well. Hey, it thinks it's done. Okay. I wonder if it's made a big mess of it. I'm just going to have a quick look. A couple of the 0805 caps are kind of messed up, but that is a fairly regular occurrence. So I'm going to click on Unload PCB and have it eject the board. And then I can reach in and take it out of the machine by hand because I don't have a conveyor, because, yeah, we all know the reason for that. All right, and so now I'm going to have to be doing some general hunting around, looking for, I'm going to switch to this view, and let's have a look under the microscope and see how badly screwed up this is. Well, focus is a bit off. I'll just see if I can adjust that. So let's, that focus is okay? Yeah, that's all right. Well, you can see the placement's not bad. Ooh, I can see a couple of problems up in the top left corner. I will get to that in a second, but most of these placements look pretty decent. Now, why are those two swapped? That is really weird. I must have screwed this up in the design in Fusion. I'm curious. See how I've got pairs of resistors and capacitors there, and then two of them are opposite? Oh, they're both grounded, yeah. They're just, it's a resistor and a capacitor in parallel, both going to ground, so they could just be swapped, and it doesn't make any difference. But that annoys me aesthetically. I think I'm gonna change that in the pick and place job. Makes no difference electrically. Now down here you can see there is a problem. See, there is an 0805 cap there. I'm just gonna grab some tweezers and put this into position down here. This one would have been dropped off the nozzle or something, which is why it was sitting out there on its own. And over here, you can see there are some 0805s that are really messed up. So those should be there, and there must be another capacitor. Oop, what's going on with that? Don't know. There must be another capacitor that should have gone on there. I wonder if it missed, like it might have misaligned and hit one capacitor body onto another, and that's why it scattered them. So there's no loose capacitor lying around on the PCB here. It might have got dropped off the nozzle or fallen off. That sort of thing does happen from time to time. It's just the reality of dealing with machines. Other things are looking okay. There's the USB connector. There are some parts I need to put on near the USB connector. And what else do we have? Oh yeah, up in the top left corner. This is screwed up here. Look at this. That LED and resistor looks good. And then if we come across there, you can see this LED was put down kind of on its side. I'm just going to flip it over. But the orientation is correct apart from that. And this one missed the pad. And why is there no resistor there? Oops. It's actually also backwards. It's just totally wrong. So I'm going to need to find out what that resistor is. It could be that it's a value that was not in the machine and therefore was disabled in the job. I don't know. I'm going to have to check that out. And you can see the diodes here. This, where is it? That one? No, that one. Yeah. So you can see the diode there. That's the SOD123 diode that was put down. This is part of the change. That diode was added because of the change to the pinout on the I/O module headers. These are all the I/O mods. And that is the interrupt connection. So it's using those. I need to find some solder paste. There's a syringe of it here, but I don't know what state that one's in. I'm going to go and grab another one out of the cleanish room. Yeah, there is now an interrupt output coming from each of the I/O modules, and it goes through those diodes to effectively form an OR gate, because they're all, it's like an open collector type thing where there's a pull-up that biases it. Solder paste? Yeah. There's a pull-up that biases it high, and then they can be pulled low, so they're active low interrupts through those diodes, so we can have a single pin going to the Raspberry Pi. I'm just in the process of adding that capacitor in. There we go. Now I need to find out what that resistor was meant to be, and also I have the syringe here with solder paste, so I'm going to squirt a bit of paste into these holes so that when the connector is reflowed, or when the board is reflowed, the connector will end up mechanically bonded to the PCB with intrusive soldering. Quite a few parts to put down. Oh yes, I'm going to swap, because it annoys me, I'm going to swap that and that. That must have been, it would have been when I was doing the original board layout that I just didn't notice that I had resistors on one row, capacitors on the other, and I'd swapped that pair. And you can see on those ones, they're all aligned. So each one of these needs, I think it's something like a 22 ohm resistor, whatever goes in series with USB, because that's the USB hub. So I need to find the value. Let's bring it up here, back to here. Where am I? Oh yeah, down. Let's get rid of that copper. Down here. What are these? They're 30 ohm. Okay. 30 ohm resistors. 30 ohm. I hope I've got enough. I don't think the value is super important. This goes in series with the USB data line. Oh yeah, I've got enough. Now, where is the chat? Scott says, I once caused a pair of 300mm googly eyes to be attached to a full-size KUKA robot arm. That's great. Yeah. Crispian said the stencil could be bigger around the larger holes where you are manual at the moment. I'm not sure what that is about. Crispian says we need a project to automate the googly eyes. Oh, Wagonlow says, can we see the video feed from the P&P placement head? It's too late for me to do that now, but that would two 60 ohm resistors in parallel. Yeah, sorry, back to, where are we? Here. Now, I'm going to try to do this under the microscope, but it's going to be kind of awkward, just so that you can see what's going on. For doing this, I don't normally do this under the microscope, because 0603s are quite large and easy to do. So I'm not actually looking through the microscope at the moment, I'm just eyeballing this directly, but I'm doing it, I'm trying to do it with the board under the microscope so that you can see it, which makes it quite awkward. What was I talking about? I don't know. I don't know. Hang on, the chat will remind me. Some call it fun. Ask, does the speed of the P&P affect the quality of the placements? A little. It's the physical structure of the P&P is actually really, really good. It's capable of quite precise and reproducible positioning. The issue is not so much in the machine responding to what it's told, it's more around the vision system and tuning that so that the bounding boxes are all accurate. I found that is more of an issue. The thing is that you do need to go slow when you've got heavy parts loaded on it. So that's definitely a consideration. Now, what else do I need to put on? Now, what was that resistor up in the top left corner for the LED? Oh, come on. R10 is a 1K5? Is that it? 1K5? Yeah, okay. It is a slightly odd value. Not super odd. I don't know why I picked 1K5. I think it was just to try to tune the brightness of the LED. So that can go on there. Yep, so there's now a 1K5 on there on the 3.3 volt rail. Now I need some SS56s. I need some fuses that go there. I need some INA 260s. I need a lot of parts actually. So I am going to go on a little part collecting expedition. How many of those do I need? 1, 2, 3, 4, 5 of those. I need 2 of those. All right. Let's move that down to there, that to there, and there. Okay, and back to here. Okay, what do I need? I need some 220 microfarad capacitors, 5 of those. 2, 3, 4, 5. I'm trying to be lazy and not get the reel down. So I need those. I need some SS56s. Where are they? There's a reel of them. Oh, right here. Reel of them here. I think I need 2. I can't remember. I also need some fuses. What value fuses? I can't remember. I think they were just 500 milliamp. Oh, I'm going to need some of these, but I don't remember how many, so I'll take the whole reel with me. I need a piezo. Do I need a piezo? I think I do need a piezo. And there is a whole reel of piezos here. I need some INA 260s. Where are they? I need a stock management system. That is a kind of inside joke. Because Mitch has been working on getting inventory set up over the last couple of days and has got a lot further than I did. Not there. Where are INA 260s? Are they up here? They might be. Funny thing is, to find where they are, I might actually have to check with my son because he's the one that, yeah, the INA 260s were used really commonly on, oh here they are, on customer boards. But there's a particular customer that uses them and he is the one that assembles all of that customer's boards. So he's got his own system set up here. How many INAs did I need? Was it 3? I'll take 3. So he knows where all the parts are. It's a pretty common thing these days that whenever I come to try to assemble something, I'm going, Tom, where is the whatever it is? And he knows exactly where everything is. All right, so I need a couple of inductors, a couple of LMR 38020s, 2 of them. Does that sound right? I think it sounds right. And probably some other things that I will figure out in a moment. This will get me started. Oh, I need the TUSB, what is it, the 25 2046, 2036, I can't remember. One of those. Maybe this is a better view. Sort of. If I zoom in, this might be a slightly better view rather than under the microscope. So I've got my, I'm going to move this over here. Got my stash of parts. And I will zoom in. Yeah, that kind of works. And then let's get the focus right. There we go. The focus will jump back out in a moment. John Whip says, need the money for therapy, my OCD in overdrive right now. 47k tombstone. Okay, so there's a tombstone there somewhere. There must be one that I missed. 47k, or are you just saying this to mess with me? Probably. Oh, there's one up in the top right. Oh, that's also a 1.5k. Okay. There's one up there that is also missing because it is not populated. Yeah, so where is this tombstone that that you were all freaking out about? The 47k tombstone. Some Call It Fun said, Mitch on Monday, this inventory looks like a bunch of squirrels were running through it. Yeah, Wagon Load says 47k is not centered on the pads. Okay. 47k. I think I see where you mean. I'm just going to check this under the microscope to make sure. Where are we? Oh, no, that's not a 47k. That one says 01C, so that's a 10k. Where is this unscented 47k? I didn't think there were any 47k resistors on this. There might be 4k7s. Oh well, I will keep an eye out, and if I find it, I will fix it. Oh, I see where you mean. You're talking about here. That one right there. Yeah, that one is 47X is the marking on it. It's that one actually would have reflowed fine, I think. Is it a 47k? It might be something else because 47x is not, it doesn't mean, yeah, 47x is like a hex value that, not a hex value, it's some, anyway, it doesn't necessarily literally mean the values, the decimal values 4 and 7. Okay, hopefully now you are slightly less freaked out about that. Oh, I needed another SS56. Okay, I can fix that later. So these are the INA 260s. I will check the alignment of these under the microscope in a second. I'm just going to eyeball their placement to start with. And yes, I know that middle one is off. That should be a bit better. In fact, they're all off. There we go. And this is an LMR 38020. Now, what are these parts? I think these were fuses. Oh, inductors go on there. What I could do, just to really break people's OCD, is do this. So they're at opposite orientations to each other. But no, that will annoy me. So I'm going to turn it around and put it back down like that. Now, those I think are fuses. I need another SS56 there. I need a 3.3 volt regulator. I need whatever those are. I'm going to leave the electrodes. No, I won't. I'll put them on. I was going to say that I'm going to leave the electrodes off until the end because they are large and they get in the way. But I don't care. I'll just work around them. Oop. I'll manage. And now what else goes on here? That is the, I believe that is the EEPROM. So I will go and find that in a second. It's like a Cat32C something, something, something. There's the 3.3 volt regulator. I need the I2C multiplexer chip to go up there. Actually, I'm surprised. It's nearly done. Apart from some oddball things. I thought it was going to take me a lot longer to put all these extra parts on. And it may still if I can't find things. Oh, here's the vertical USB-C connector. Stick that on. There's one here. I hate these things. I'm going to stick that right there. Okay. It's got the plastic cap on it so the pick and place machine can pick it up. Okay, but I need to do those three thingies, whatever they happen to be. I need to find a better alternative to that vertical USB-C connector. They really do suck. They are horrible, horrible things to work with. So now I need to know what is beside the USB-C connector. Okay, so we've got 22 picofarad. Now, which ones am I missing? I need first, third, and fourth. So I need a 1K5 and a couple of 30Rs. Okay, that makes sense. A 1K5. I should put a reel of 1K5s in the machine because I do end up using them a little bit, and so I end up hand placing them all. And if I do much more stuff with USB on it, then 30 ohm resistors are also a really common thing because they're, because they are in the data lines of a lot of USB connections. So a couple of 30 ohm resistors there. Oh, you couldn't see that. There. Now, what else do I need? Oh, that is the oscillator for the USB hub. All right, I'll get the easy ones. So I need to figure out what those are, and I need another SS56. So what they are is 1 amp fuse. Okay, so that's a polyfuse. And then what are these? Oh, those are the 4U7s. Okay, that makes sense. Normally I would have more 4U7s on a thing like this, but I've got bulk capacitance on the... Yeah, there's plenty of space. Anyway, I don't know what I'm trying to say. No, actually what I'm trying to say is that often when I'm using these voltage regulators, I will have an array, like, not an array, they're basically like a row of 4U7 low ESR high voltage caps on the input side. But in this particular case, I've only got one on each of them as like a little decoupling thing. And it's got bulk capacitance elsewhere, here. So I need a voltage regulator, SS56, and a couple of fuses. All right, fuses. Where did they go? Oh, over here. There's a reel of them here. Another thing that I should put in the machine. There are a lot of things like these sorts of fuses that it's fairly common to have one on a board, and if you've only got one placement on a job, it's only barely worth putting it in the pick and place machine. But when it gets used on just about every board, I mean, things like 10K and 1K resistors, obviously you want them in the pick and place machine because there might be 10 of them on every board. That, and I need the SS56. And then I will start getting into the exotic stuff, like the I2C multiplexer. That. I need that. How am I going for time? Am I totally blowing my time budget? I'm pretty much at the end of time, but I will getting a lot more exercise. Yeah, I am getting a lot of exercise. So there's the 3.3 volt regulator. And the other SS56. Then the fuses there and there. Now I can't run drastically overtime today because I have Plasma Steve coming over to work on a project for a little bit, which is a control system for the tool turret on his CNC lathe. I am working on a new controller for it to integrate with Linux CNC. So some of you will remember like a year ago. Okay, I need to look up what parts these are. Oh, and I need the, okay, I will get that, I'll get that first before I go on with that thing about the lathe. So I need the Cat 24C32, that is the one. I2C EEPROM, I need one of these. Yeah, some of you will remember when I was struggling with that grey code rotary encoder a year or so ago, and Austin found a data sheet for it, and then it all started making a whole lot more sense. Yeah, it's that project. So I need to make a board that is going to interface with the encoder, and we'll have an RS422 interface that talks to the board that is connected to Linux CNC, so it can do automatic tool changes on his CNC lathe. All right, I think I've only got 3 parts left to go on, and then I can chuck this in the oven. I need the USB hub, the oscillator for the USB hub, and the I2C multiplexer. And I have a feeling that those are specifically set aside in the Testomatic box. They are not in general circulation with other parts. So I have a box with all the parts here, specifically for Testomatic. Not that, not that, not that. Although they might be in general circulation. Oh, oscillator, here we go. That is the oscillator I need. That is the I2C multiplexer that I need. And that's the USB hub. Perfect. And I think that means that we are 100% complete on parts. So this is the USB hub. I haven't read chat for a little bit, but I saw a comment there earlier about something about my OCD. I think it was from Crispian, saying my OCD must not be too bad because I tolerate a lot. And it's, no, I think it's just that I deal with the anxiety. Things can annoy me from an OCD point of view, and I just let it grate my gears, grind my gears, and put up with it and have a slightly higher cortisol level as a result. All right, in a second, I'm gonna chuck this back under the microscope and check. Oh, what's the orientation on that? There's no orientation marker on the PCB. I think pin 1 is in the top left, but I don't know. That was an oversight. Let's find out. Where is the I2C multiplexer? Oh no, it's at the bottom. Pin 1 is in the bottom right. Well then, it's a good thing I checked. So this has to rotate 180 degrees so that pin 1 is in the bottom right. Oh, come on, bumpity bump. There we go. A little bit more. There. Ah, there. I think that's close. I will microscope check that momentarily. All right, last part, the oscillator to go on there. And then, what have I got here? TUSB. Oh, that's the bus. Okay. Talking to myself. And the oscillator. So, I have a problem. The problem is, I want to submit a talk for everything open, and the talk submissions close in a few hours' time, and I can't think of anything to submit a talk about. I've actually considered submitting a talk about Testomatic and using that as motivation to make me make more rapid progress on it. Because if there is a talk coming up, just doing a quick alignment check here. Yeah, that's fine. It'll get pulled into line by reflow anyway. The I2C multiplexer is the most critical of these, apart from the USB socket, but that's constrained by its mechanical corner pins. Yeah, that looks all right. Just a slightest jump, nudge. There we go. Okay, I think this is ready to throw into the reflow oven. So let's go to there. Unfortunately, the camera is at totally the wrong end of the room, but what I'm going to do is just put this into the oven and then come back and check out some other things. Okay, it has begun. Oscillators, that. I need to put that away. And, oh, hang on, Stuart is at the door. Just a second, I will see what he's up to.
We're going to get some stuff for a barbecue.
Oh, I'm on live stream at the moment.
Do you want to do some lunch when we cook it?
No thanks, I've got someone coming over soon anyway.
Okay.
Thank you. So, that was Stuart from over the road, as you would have heard, checking if I wanted some barbecue. What's that one? That is the bus switch. Yeah, I'm gonna have to do some cleaning up after this. Put stuff back on in the right place on the bench. Now, what am I doing? Okay, I'm going to check the chat. Check the chat. Get rid of the gloves. That feels better. Okay. Do talk about designing it in public with snarky inputs from the viewers, says Scott. Scott says 47x beside the one he fixed is going to tombstone. Maybe. We shall see. Yeah, what is it? My clock is 10-ish seconds slow, or is the stream delayed that much? Use nails instead of foil. Speaking of Steve, Austin is ace. There's a whole lot of comments from Crispian. Yeah, Crispian says, the stencil has done such a good job. I keep thinking there isn't any paste until I realised the pads would be gold without. Yeah. Are they polarised? I am... I am behind on chat. All right. Oh, Crispian asked, when is Stuart leaving? He actually already has. They're in the process of cleaning up that factory now. They've been in the new factory for a week. They actually did the big move last weekend, and then Monday just gone is when they started building stuff in the new factory. So right now he's in the crossover period where he's cleaning up the last stuff out of the old one, and is in production in the new one. So during the week this week he's been here a bit, but not full time. Crispian says sad to see him go. Yeah, definitely. He's a good character to have around. He's really cool. Oh, Crispian said probably end up with crap neighbours. No, what we are going to end up with is nameless, invisible neighbours, because the people who have taken over the lease is Placard, the company that does like Visa and MasterCard and driver's licenses and all of that sort of thing. They have a heap of factories around here, including the factories on both sides of Stuart's factory. They already have the one to the right and they have the one to the left. And he was like a holdout, one factory in the middle of the Placard empire. So what they did was make a deal with him where they have paid him to leave early. His lease isn't actually up. He took out a lease on a new place and moved to it because Placard came and waved money in front of him and said, we will pay you to break your lease and let us take over your factory. So that's what ended up happening. Keith! Good morning, Keith. Michael says, well, at least we know where to go for fake IDs now. Yeah. Yeah, real fake IDs, as in fake IDs that are made in the real factory. They have so much security theatre there. I think I've mentioned this before, but so the coffee roaster that is right next door to me, people from Placard come over and grab coffee there all the time, and they're not allowed to take coffee cups into the factory because it's considered a security risk. Because like, what if you've got something hidden inside the coffee cup? You might have IDs or something in it that you've manufactured, like fake IDs that you've made in the factory, and you're taking them out in the coffee cup. So they have to use transparent coffee cups, like glass, and so they come over to the coffee place with glass drink flasks and that sort of thing. And so every now and then, yes. Anyway, that's the sort of weird thing. So I was talking to one of the Placard guys during the week, actually, because I noted he used to have this really fancy glass vacuum flask, and he came in with something different. And I said, what happened to your fancy thing? And he said, oh, he broke it and had to buy a different thing. And, and he was saying how ridiculous it is because they're not allowed to take coffee cups into the factory, but they can walk in wearing a jacket with pockets. Like, and they're not actually searched. So, like, he was making the point, they go to all the trouble of stopping you taking a coffee cup into the factory, but you can just walk in with stuff in your pocket or walk out. Yeah. Jack's Tech said, not security theatre in the environment that prints the ID cards for defence. Yeah. Michael says, we get our butts kicked if we wear ID badges outside of the office. Yeah. So for many reasons, that is quite valid. Ideally, you do not want the design of your ID badges to be known outside of the company so that it's not easy to make a forgery. Because if it's an RFID badge or whatever, then you don't want it to be skimmed and get the ID from someone in a coffee thing. Crispian says it raises awareness of the concept. Well, that's true. Yeah, that is true. If you make people think about it, then I'm just keeping an eye on the reflow oven because that board's been in for a couple of minutes now. It must be a fair way through. Oh, I can see it. It's about to come out the exit. So in a moment, I will grab the PCB when it comes out of the oven and chuck it under the microscope. Scott says, time for Deviant Ollum to visit Australia. Yeah. And Michael says, well, there are other reasons we can't wear them, but I can't say what they are. Yeah. Okay. That's cool. So here it goes. It just went clunk. The board just fell out of the reflow oven. Jack Sec said, just look up Deviant Ollum if you want to see how easy things can be to swipe. Yeah. Deviant has done some amazing conference talks about penetration testing and hacking different things, getting into secure facilities and all of that sort of stuff. So I just turned the oven off, put it into cool down mode, and let's see if the tombstone fears have come to pass. It is time for inspection. So let's be a little bit organized about this. Start in the top right of the board. That all looks fine. Fuses there look fine. And then move across to the top left. Those are fine. Oh, look at that. It's a thing of beauty. It's a little bit hard to see on camera. It is definitely easier to see with your eyes through the optics than it is to see on the camera. But all of those solder joints, oh, I just heard the air compressor turn off, so it's still running. All the solder joints look spot on. This is the I2C multiplexer. No bridges or anything, that all looks perfect. They all look fine. And coming down to here, these are all the parts next to the USB hub. They are all fine. The USB hub itself. Yep, no bridges or anything on that. That looks good. The oscillator looks good. Yeah, memory chip seems fine. Coming along to here, the power supply region, that's the 3.3 volt regulator with its decoupling caps. Those are the pull-ups for I2C. Here's one of the voltage regulators with its inductor, and across to the next voltage regulator with its inductor. What else do we have? Oh yeah, so here's an INA260. These are quite fine pitched as well. That looks spot on. Everything aligned. Ooh, this INA260 is twisted a little, but it still looks acceptable. Look at it's a little hard to tell. See how those top pads are not quite aligned? It's slightly twisted off to the right, and the bottom pads are aligned, but the whole thing is slightly low. It's like it's moved a little bit in reflow. I could fix that with, in fact I am tempted to, just to make it look nicer. I am pretty confident that this would work fine. I can't see any solder bridges. It's not displaced enough that it's a problem electrically, but it is a problem aesthetically. And this one is also slightly offset to the bottom. I wonder what caused those to move. That is interesting. All right, I am tempted to throw this on the hot plate and just bump those parts very marginally. I'm going to do it. I'll steal the hot plate back from Tom, because he was the last person to use it, and go back to overhead. All right, my little mini-ware hot plate. Which one do I want to use? Power supply 1, because it's got a higher current rating. Go for 24 volts. Set it to 8 amps will do. There we go. And go. Oh, what? Over temp? What does it mean over temp? Oh, it's I didn't change the current limit. Now it's on. Oh, I set the voltage to 8 volts instead of to 24 volts, and I set the current to 8 amps. There we go. So now it's heating up. I'll put it into a higher temp profile. I'm going to turn it around so that the board is upside down, because that's going to give me better access to those particular parts. It is this one here and this one here. Those are the INA 260s that I want to straighten up just a little bit. It'll take a while for that to get up to temperature and for the heat to soak through. This is a 6-layer PCB, and there are polygons on, like pores on all 6 layers, which means getting the heat through it is going to take a little while. I'm going to let that sit there and soak. So what I'll probably do is let it get pretty hot and then just hit it briefly with hot air on the top to bring it up. Okay, so what's going on in the chat? What's going on in the chat? Oh, David C asked how far has he moved? So this is talking about Stuart. He's moved to sort of the Kilsyth-ish area. It's maybe 10 minutes drive away on if the traffic is busy, a little bit less if it's quiet. So it's close, but it's not super close. Oh, Jackstack said, what the heck are they using that much floor space for? Is this talking about Placard? I don't know. It's a big company. They got a lot of machines. They got a lot of staff. Some call it fun, said, place your bets for Tombstone. Yeah, no tombstones. Stephen says, seems to need just a few seconds longer to reflow the large components. I don't know. Yeah, so Scott asked, is it possible those two parts are where the paste was slightly offset? In theory, that shouldn't stop it. Ooh, some call it fun has a to-do list thing. Add orientation for I2C multiplexer. Yeah, good point. Okay. Sorry, I'm just listening to that. I just heard a little creaking noise, like thermal expansion and contraction noise coming from the PCB. I'll throw it back to here for now. Yes, thank you for that to-do list. I need to switch those things. Now, in theory, the surface tension should have pulled it straight. So I don't know why. Yeah, these are not yet moving. I can feel it is pretty hot. I could, actually, where is my thermal thingy-majigamy? Let's see if I can get a temperature reading off this. What is it saying it's at? 200 degrees. And 200-ish degrees around that area at the moment. So it's getting up to sort of reflow area for, it's getting close for lead-free solder. It'll already be flowing now, I think, if this was leaded, but this is lead-free, so it's taking a little bit extra. Okay, now that it's this close, I think I'm gonna, my iron is not, my hot air is not turned on. Where's my phone? Where did I put my phone? I needed to turn on the hot air. Or I could just be patient and wait for the hot plate to do it. But no, I'm going to find my phone. Yeah, was Deviant Ollam in Australia recently? He might have been over to talk at a conference or something. There might have been like a Tinker has sent me a link for something. Okay, I'm going to turn on the bench. Bench 1 on. Okay, which will give me hot air. But let's see if this is now up to temperature anyway. I may not need the hot air. Yeah, not quite. All right, it's hot air time. Come on. Get up to temperature. You can do it. Just trying to coax it across a fraction. Doesn't need much. Yeah, that's right. So what I was saying is that surface tension of the solder should have pulled these parts into alignment. I'm not quite sure why they didn't. There we go. That's moving now. And this one should be right on the verge of moving. Oh, I've just melted the plastic on that cap, which is unfortunate. All right, I think they're a bit better aligned now. Maybe not perfect, but good enough. And unfortunately, yes, I melted the plastic right there and just a little bit right there. So those capacitors look slightly molested now. It's a trade-off. All right, this is cooling down, but it will still be quite hot. So I'm just going to lift it off and sit it on the bench so that it's not getting any of the residual heat from the hot plate. Move that back out of the way. Oh, look at this. It's actually melted my support. Look at that. Because the heat flowed sideways across the PCB. So I might have melted plastic on the bottom of the PCB. That would be annoying. Oh well. What I need to do is reprint those little supports in polycarbonate, in like high temperature polycarbonate. Ah, Crispian says, Ollie says hi, he's visiting with Emmy's mum, come to pick up Amelia, Emmy's little sister. Well, hello. Debray says, kept on tape is your friend. Yeah, I know. Phone is at the PNP. Yeah. Does the I2C footprint have a pin 1 marker? What do you mean by the I2C footprint? All right. Now, I am normally very much against modifying existing designs and not keeping a copy, because, so my policy basically is I always want to be able to see the design exactly as it was at a certain point in time. And yes, there is version control and all of that sort of thing, but my preference is to actually create a new version. So on the left here, for example, you can see Testomatic 2.2 and Testomatic 2.3. And one of the things I like about that is that it means that I can have both of them open at the same time and see differences between them. And that sort of thing is a lot trickier to do when you're using revision control. So so these are versioned, but there are also copies. So the copy is like a snapshot at that point in time of that release. So the version 2.3, I want to always be able to go to that exactly as the board existed. However, here we can see that where is it? So that is 15K, and up the top here you can see these three are the capacitors. That is the capacitor, and then these are the resistors. So what I want to do is swap that capacitor, sorry, that resistor with this capacitor, and I want to add an orientation marker. So I'm going to do both of those things. This is kind of breaking my own rules, but I'm going to do both of those things because my rule is, if I was going to summarize it, this is how the rule would go. Anytime I have done a release, like say a 2.3 release like this one, and had the boards fabricated, I never save the design from that point forward. If I go into the design like I am now and I mess around and it's marked as unsaved because I've just done stuff in it, I never save it. I always close it without saving changes so that the file that I have there always matches the version 2.3 hardware that is in reality. However, I'm going to break my own rule now and move that and put that onto there and then route that track because, because that is not an electrical change at all. It is simply swapping the location of these two parts mechanically on the board, and it makes no difference in terms of the pick and place job. Well, actually it does affect the pick and place job because the coordinates for those two parts are now swapped. So I'm going to go and swap that in the pick and place job. So if I make another one of these boards, it will exactly match this. But it makes no difference in terms of the PCB. The Gerber files that come out of this would be the same because this is the same footprint. It's just the parts that are swapped. Okay, now over here, I am also going to put a little orientation marker on here. So I'm going to go for like a 0.1 grid. And you can see there's an orientation marker, but that is in the document layer. It's not in the silkscreen layer. So I'm going to put a, oh come on, get out of there. I'm going to put a circle here using the, in the T-place layer, and I'll put it just like here somewhere. That'll do. So next time, if I make modifications to this design, what I'm going to be doing is taking the, let's make it a bit thicker. I'm going to be taking this snapshot as it exists right here. Let's make it 0.254. No, even bigger. 0.3, yeah. I'm going to be taking a snapshot of this design and then applying modifications to it. So these are non-functional changes that I'm doing right now. Then I'll set the grid back to 1 millimeter just so it gets saved that way. I'll re-pour the polygons. Let's move that out of the way. Show all the polygons and rat's nest, 2 air wires. Where are those air wires? I have a feeling that they are ones that are not, yeah, they're approved. So I've got air wires, 2 of them, that I specifically ignored. And that is because, nah, I won't bother getting into this now. I won't explain it. But these 2 voltage regulators have the same signal name on those 2 pins, which means that Fusion thinks that there should be a net between them, and there shouldn't. And the signal name, and that's the same thing that's happening on here, V+, V+. I don't actually want them joined. So, well, I don't care about them being joined, is a better way of putting it. So I have left that unrouted and approved the error so that it doesn't complain about it when I run DRC. Tool size. Alright, so now that I've done that, I am going to save this. So that is the 2.3. Oh, what I can do is come to here. Okay, so which locations do I need to switch? It was these ones. So I want to switch C28 and R42. Okay, C28 and R42. I will come down to C28 is at coordinates 73, 23. I need to start writing these things down or I'm going to screw it up. So C28 and R42. So C28 is at 73, 23. And what is R42? Where is R42? Is down here, and that's at 73.25. Okay, so they're on the same X position. They're just 2 millimeters apart. So what I will do is make this one, whoops, not that one, this one. I'll make that one 23 millimeters, and on C28, come on, back up here, C28, that one there, instead of 23 millimeters, I'll make that one 25 millimeters. There. So now the pick and place job will put them down. Oi. I forgot that I'm on a remote machine. Yeah. Save job. Yeah. So now if I do another placement, it will swap those two parts and they'll be put in the correct coordinates. Validate 23 saved. Look like 2, says some call it fun. Okay, let me check. So I've got C28, that one there, should be 73.25. Yes, that's correct. And now I'll look at R42 again and validate that one. So R42, you are absolutely correct. Some call it fun. So that should be 23 millimeters. 23. So that should be 23, the other one's 25. Yeah, okay. Thanks for catching that. That was well spotted. And then back to C28 to verify 25. Yeah. Cool. All right. Save job. Save job. So, I'm going to have to stop the stream. It's 12:38. Okay. But at least we have successfully done pick and place on that. So I'm going to exit out of OpenPNP. Yes, save the board. Save. Yes. And I'm going to bail on that remote desktop. I'll go and turn off the machine in a little bit. And what are we doing? John saved the coordinates for me. Thank you very much. Overtime is for bodging and corrections. Yeah. I2C multiplexer footprint pin 1. Yep, that's done. Yes. All right. Well, hopefully it's cooled down enough now. Oh yeah, one thing I should do, the very last thing, I'm going to go back under the microscope and check the realignment job. I hadn't actually looked at that. This is the one that was not modified. So that's how it came out of the oven. This one, yeah, it's looking better. It's not perfectly straight, but you can see that it is more overlapping the pins now. And this one is spot on. So the middle one still has a slight twist to it, but I'm not going to heat it up and reflow it yet again. It's on enough that I am confident that that's going to work fine. It's just not quite as aesthetic as it should be. And keep in mind that this is tiny. If you just glance at this with the naked eye, you probably wouldn't even notice that that part is slightly twisted. It's hard to tell. So now we have this board Oh, look at that. The zoom is almost perfect. So now we have this board assembled, ready for headers and relays and all of the other bits and bobs that need to go on it. And then I can start doing some testing. And I also need to assemble the modules that go into these, the new I/O mods. I've got the boards, I've got the stencil, I've got the parts. I just need to assemble some. And then it can be tested. So I am very tempted to submit an everything open talk proposal based on this board. Well, not just this board, but the whole project. You know, the Testomatic project in general. Scott says next week smoke test. Maybe. I will probably do a smoke test before next week because I am anxious to make progress on this. Tabrez said, what's the name of the component search engine people are using lately? It was mentioned a few streams ago. Oh, there's Octopart? Maybe? That might be the one you're thinking of. Octopart. I'm going to bring this up. See if this one is the one that you're thinking of. So, oh, go away. So Octopart searches by different categories. So if I wanted to search for, say, ISO 1042, which is the opto-isolated CAN transceiver, that is not it. That's an eval board. Yeah, that one, for example. So you then pick the part and it then shows you stock and prices and things at different suppliers. And you can check inventory history. So you can see, oh yeah, it's been pretty constant at 70,000 parts in stock since June. So no problem on that one. It's a very stable stock level. Yeah. Oh, Tabrez says, no, it looks like the JLC part store. Oh, okay. Yeah, in that case, I don't know. Maybe there's a front end for JLC. I know there are actually alternative front ends for JLC. Scott says, imagine if you did the talk with a chat TTS in his ear. Well, that's a possibility because everything open is streamed live. And I could organize it that I have like an inner ear monitor and have, if you were watching the live stream of everything open and the TTS could be set up to send messages to me, that could be really annoying for the people in the room anyway. I'd be able to hear your TTS and nobody else would. Crispian says, yeah, submit the talk and wing it. Yeah. Oh, Scott says, turn on the cameras if you test off stream. Yeah. Yeah, maybe I'll do an impromptu live stream. Maybe. This is the voice in your head speaking. Yeah. Okay. I'm going to have to go because I think Plasma Steve is probably going to be here pretty soon. And I will follow up next week. So think about things during the week that you can be proud of. Little achievements, little things that you've done. And share them with us next week. So, until next week, same bat time, same bat channel. Go and build something awesome. Thank you.